Okay, so as we're getting started, kind of jumping into the parts for this arbor press, I wanted to show you the assignments that I have here. This is going to be very similar to the assignments that we had in our first project. So you're going to notice here that we have assignment two part models, assignment two assembly models, assignment two detail drawings, and then the assembly drawing is fourth. So I broke them out into those elements. So as we look at the part models, I'm going to click on the part models here. You're going to notice that you are going to be saving each one of your files again as part numbers, and I've assigned part numbers for you. They are in this first assignment for the part models. So our frame is going to be 310. Our RAM is going to be 320. Our pinion shaft is going to be 330. So as we are creating our part in Creo, we are going to be saving it as 330. And then the common name is going to be pinion shaft, all caps. Okay. So don't use the names that are here for your file management. You want to use the numbers that we have here. So again, this is an assignment two part numbers. We are going to be looking at the pinion shaft in this video. So we're going to be calling it 300 or 330. Okay. So I'm going to go to Creo now. And I'm going to start a new drawing. Before I do, don't forget to select your working directory. So make sure that that's set up first. And then you're going to start new. It's going to be a new part. Our file name is going to be 30030. And then the common name, all caps, because remember, this is going to pull on your assembly drawings. This is going to be pinion shaft. Okay. And for this, we're going to just use the default template because this is just for a part. This isn't for a drawing. So we're going to say, okay, oops, of course it is. I need to do an _1 because I already created mine. Don't do the _1 for yours, just do 330. And now we're going to be at our familiar spot. So let's take a look underneath our camera at this pinion shaft. So we are going to be creating the tooth profile of the shaft, and you can't really see a whole lot of detail here. So something you're going to notice is that this is called out as a 20-degree stub 12-pitch gear. And down here, it's going to mate with a ram that is also a 20-degree stub pitch or 12-pitch stub gear rack. Okay, so this is a rack and this is our pinion. Now, as I was doing some investigation, stub gears are actually gears on the actual gear itself, are quite old time school stuff. Okay. And when I was looking at these, they actually have a curvature to them. So stub gears typically are going to be a very up and down, like just a triangle looking gear tooth, where a spur gear tooth is going to actually have some rounded curves to the sides of it. Now, in doing some investigation, I was having a hard time finding the equation for the teeth for a stub gear, but in finding out, and I checked this in a couple different places, spur gear teeth, standard spur gear teeth mesh with stub gears. So stub gear teeth on a rack. So what we're going to do is we're going to actually use what we call the involute tooth profile for a standard spur gear for the teeth on our pinion shaft. But we're going to use, you know, as it's directed here on the rack, we're going to use the stub teeth. Okay. So, so these two in combination, even though we're deviating a little bit here on the profile of the gear tooth, they are still going to mesh properly. Okay. So we don't have to worry about that. So we are going to take the approach of spur gear profile as opposed to the stub tooth profile of these gears. Now, as we look here, you're going to notice that the gears don't extend the whole length of that shaft. What they do is there's going to be a section here where it goes straight for an inch. That's where it says 1 inch of full teeth. And then they're going to kind of like sweep out of the actual shaft itself. Okay, so that's what we're going to be creating in Creo. We are going to actually be creating the cuts out. We're not going to create the individual teeth. We're going to create the portions that we're going to cut away so that the teeth are left over after that operation or after we create those teeth. Okay, so the process is going to be, we're going to create a sketch of the profile of the cut, and then we're going to do the trajectory of the path that that cut is going to take. This is a sweep. Okay, a simple sweep is going to be one single sketch cross section that we're going to run along a path. An extrude function is actually a sweep. Okay, except it's in a straight line function. Okay, it's the trajectory is on a straight line. So we don't call it a sweep, we just call it an extrude. But it is a form of a sweep. But in the case of the sweep that we're going to be doing, instead of putting it just along a straight line, because we could extrude that in, but because it's kind of like going up and out of the shaft after that 1 inch, now it becomes a sweep because now we have to push it along that radius that's created. We're not given information about that radius, so we're going to improvise here. This happens in design. This happens in engineering at times. Sometimes there might be a missing dimension. Sometimes it's kind of like, okay, as the designer, I got to kind of fill in the blanks here. There's going to be a couple places along the way for this arbor press that is going to occur. That's kind of the fun part of it. You're going to be able to be a decision maker at some points. Okay. So anyway, so that's going to be the approach that we take. Now, what I have done and what I've gathered for you guys is in the handouts that I have, there are 2 of them. The first one is that we're going to be kind of referring back and forth to our imperial spur gear technology or terminology. So this is going to equate to the elements that we're going to be creating for the tooth profile in Creo. The other handout that we have is the pinion shaft procedure. So I'm not going to say it's a perfect step-by-step, but I've kind of hit the highlights that you have to kind of move along. And I'm going to be demonstrating this today in our lecture so that you have, the information you need to kind of get this gear teeth cut into that shaft. Okay. So because we're going to be dealing with the spur gear profile, the profile of the tooth looks like this. So this is where we have kind of this curvature on the sides of the tooth. Okay. We have our pitch diameter going through, not exactly the middle of the tooth. We've got what we call the addendum, which is the top portion there, and we have the dedendum. The dedendum is always going to be deeper than the addendum of the tooth. And the reason for that is because this pitch diameter is where it meshes with the other, if you would, tooth, or in our case, the rack. And that's what we call the effective diameter. This addendum of the mating tooth is going to be down in the dedendum of this tooth. So the dedendum always has to be deeper than the addendum would. Otherwise, you would have gears that are going to be colliding. All right. So addendum is the height of the tooth above the pitch circle, and the dedendum is going to be down below. Okay. Then we have we call this the circular pitch. The circular pitch is a distance along that pitch diameter where if we take one point, and it can be any point on the tooth, to the very same point on the next tooth, and that's a distance between. That sets what we call the pitch of the tooth. When we look at gear teeth, some of the terminology is down here. So we've talked about pitch diameter, which is this diameter right here going all the way around. Number of teeth are going to be physically the number of teeth that are going to be around a gear. Now, diametral pitch, these two sound similar, but they're different. Diametral pitch is what I like to say is the size of the tooth. It's a ratio of the number of teeth in that gear to the pitch diameter of that gear. All right. So the larger the number, the smaller the tooth. The smaller the number, the larger, the bigger, the chunkier the tooth. Okay. So diametral pitch is going to be how big or small the profile of this gear tooth is. The pitch diameter is the actual diameter going all the way around where it would have physical engagement with the mating gear teeth. Pressure angle. Pressure angle is the angle at which we get contact from one tooth to another. Know that there's 3 main pressure angles. There's 20 degree, which is the most popular, 14.5, and there's 25. 14.5s no longer are made for new gears. We don't make any new designs with 14.5. We'll talk about that in machine elements and why that is, because there's some mechanics to it. So those are only for replacement parts, but they're out there. New designs will only be 20 and 25-degree pressure angles. Okay, just so that you know. So that's why we're using a 20-degree pressure angle, which is very common. Addendum, we said, is going to be the distance above the pitch diameter to the top of the tooth. Dedendum is going to be down. And then we have the root diameter. The root diameter is going to be a diameter that is measured around this is called the very bottom, is called the root of that tooth. So that's going to be the root diameter. Additionally, some other terms that are on here that we don't mention down below that we're not going to be using in our case would be, for instance, face width. If we had a traditional gear in front of us, it would be a certain thickness, and that is what we call the face width of the tooth. Looking, I think everything else we kind of looked at. Tooth thickness, we won't be worrying about for ours. Oh, working depth, that is going to be the distance from the top of the tooth to the what we call the clearance circle, and that's before the bottom of the dedendum. So, so kind of looking at that terminology, if you need to go back to this, it kind of gives you an overview of what that is. Okay. So let's look at then, secondly, our procedure. So we're going to be kind of going between these two. And the procedure that I have here is, you know, how we're going to be creating this sketch and getting everything in place so that we get the right profile. So the first thing we're going to do, you're going to notice we're going to start a new part just as you normally would do. We're going to identify the working directory, part number, part name, and such. And we already did that. Okay. Then what we're going to go through is we're going to add in parameters. So we're going to start we're not even going to worry about laying down any circles or things yet. We're going to start with creating these parameters and identifying our relations. Okay. So to do that, we're going to go into the tools menu. We're going to go to D equals relations, and then we're going to go to local parameters. So I'll show you what that looks like. So I'm going to go to Creo. Here is, you know, just where we get when we normally start a part. We're not going to go into any menus to create anything at this point. We're going to go up to the tools tab, and we're going to go over to the D equals relations. And we're going to click on that. Okay. What we're going to be doing is we're going to be setting up our equations and our relations so that we can create these gear teeth. Now, at the top here, these are relations. These are going to be the equations that we write. But before we can write the equations, we need to identify our parameters or variables. So we're going to expand the local parameters down here. Okay. Now, at the bottom, there's some canned ones that are in here. All right. And we're just gonna, I think we can just hit the plus key down at the bottom. Okay. And what we're gonna do is we're going to put in the items that we see below. Okay. So we're going to add in, I'm going to go back over here. Now I just remembered I'm going to have to adjust something, but we are now going to put in the items that we see here. So we're going to do N. For the name, it's just going to be the name of our variable. The value is going to be 12. And in the description column, we're going to put number of teeth. So I'm going to go back to Creo over here. Again, after hitting the plus sign, this is going to highlight. I'm going to put N. And then you can leave real number in the middle. The value is going to be 12. And then we're going to go over a couple columns to description. And that is going to be number of teeth. Oopsie. Okay. And then you can hit enter and then hit plus to do our next one. So I'm going to go back underneath here. You're going to do phi, which is the pressure angle. That's going to be 20. And the description is pressure angle. And we're going to continue to do this all the way down. Okay. For the ones that don't have values for anything in the middle here, you don't have to put anything in. Just leave it blank and then just go straight over to the description. So I'll give you a chance to fill those in. No. No, you don't need to add units. Good question. What was that? The part file, correct. These will save to the part file.
Which one did you say we weren't doing?
The gib plate.
For that one?
Yep, we will not be doing the gib plate, correct. So now we're going to notice that we're ready for step 3. So we're going to be copying and pasting this portion up into the relations at the top of that dialog box. So I'm going to go back to my Canvas Module 2 learning plan. And what I want you to do is the Module 2 pinion shaft parameters and procedure, you're going to want to download that Word document, okay? By downloading that and opening it, it's the same procedure that we have here. You want to enable editing. And now what we can do is we can copy this, okay? So I'm going to do right click and just hit copy. And then I can go back to Creo. So this is step 3, go back to Creo. Okay. And now up in the top where the relations are in this dialog box right here, I can do Control V. And it looks like I just have to backspace here to get these all in line on the left-hand side. What these are the equations that are going to relate our elements, back to the pitch diameter, the D-dendum, the A-dendum, the things that we need for sketching that profile. Okay, so we want them all in line here. And that way we don't have to retype them. So notice that DP, which is the diametral pitch, this is equal to the number of teeth divided by the pitch diameter. Okay, we put in values for our number of teeth, and we put in values for our pitch diameter, our pitch diameter. And then you're going to notice that for B, our D-dendum, the equation is 1.25 divided by the diametral pitch. So it's going to take our diametral pitch number then, and it's going to use it in these equations. Now, we need to verify these equations first. So you need to click on the verify relations key or a little button over here on the right-hand side. And you should get relations have been successfully verified. Okay. As long as they're all over on the left-hand side there, delete those spaces if you need to. Now, once we have that, what that says is it understood all of these values here. And now when we go down to the local parameters that we left open for a value, they now have values in them, okay? So you'll notice that DA has 1.1667. DD, which is the D-dendum diameter, is 0.7916. Now, on that handout, you're going to notice that you're going to verify those relations, and now these items should all match these values. I'm not going to go through and read all of them to you, but you're going to want these to match. If they don't, then something wasn't typed correctly in one place or the other, okay? Now, once those match and you're good, you can simply hit OK at the bottom of that dialog box, okay? So now if we look underneath, we hit OK, we're ready to start a new sketch on the front plane, all right? And we're gonna draw 3 circles that all have their centers at the origin, and we're just gonna draw them as random diameters. So I'm gonna go back to Creo here. I'm gonna start a sketch. We're not gonna do the extrude, so we go back to the model tab. We're gonna go to sketch. We're gonna sketch on the front plane, and we're gonna hit sketch. And now we're gonna create 3 circles, regular circles. Center is gonna be at the origin. Here's our first one, our second one, and our third one. All are concentric at random distances, and you're gonna hit your middle mouse button to get those in place. Now I'm just gonna kind of offset my diameters here so that I can see which ones are which. And then this one I'll kind of put up here. Okay. All right. So now we've got a small one, we have a middle one, and we have an outer circle. What we're gonna do is we're gonna assign those variables that we just did to each one of those, okay? The first one we're gonna do is gonna be the smallest circle, and that is gonna be the DD. That's gonna be the dedendum diameter. It's the smallest dedendum, or like the base circle, if you would, sometimes called. So I'm gonna go to my smallest one, I'm gonna double click on it, and I'm going to key in now DD, okay? I think it has to be in capital. It may not have to be. DD. Once you hit enter here, it says, do you want to add this relation? That means that this dimension D1 is going to be equal to your dedendum value. And you want to say yes. Okay. So now it automatically updated that value. If we would go back and look at the relations, or if you look just directly above, DD was 0.791667. And sure enough, now that's the diameter here. It assigned that from those relations we created earlier. Okay. Now we're going to go to the middle one. We're going to double click on it. And if you turn the page on the next page, in that same step, this one is going to be DP. This is going to be the pitch diameter. Okay. This is what we call the effective diameter, where it meshes with the other teeth. So this one is going to be DP. So DP, enter. And yes, we want that to be added as a relation. And you're going to notice that this went to 1 inch. The pitch diameter of this set, if we look back underneath here on the previous page, our DP is 1 inch, okay? And then the last one, the outside one, we want to assign a DA for that one. I'm sorry, DA for that one. And that's this one. So DA, enter, yes. And now that's at 1.167, which is the value that we should be seeing there as well. Okay. So now we are ready for step 8. Step 8. So what we just added are 3 diameters. The first diameter, the smallest one, was this diameter on the inside here at the bottom of the root of that tooth. The second diameter is the pitch diameter that we see right there. And the third diameter was this outside diameter at the top of the tooth. Okay, those were the 3 like reference circles that we have. All right. So now we're ready for step 8. Okay. We want to now change the name of that sketch that we just created, or I'm sorry, we're going to hit OK. We're going to accept it, and we're going to then change it to sketch gear circles. So if we go back to Creo, we want to go here, double check your feature requirements, make sure that you have your 2 green check marks, and we're going to hit OK to accept this sketch. Now we're going to rename this sketch, and we want to rename it as sketch gear and then circles. Okay. Now step number 9 says on the model ribbon, we're going to click on, and this is kind of just a sequence of things that we have to do to kind of set up the next portion here to create our curve. So we're going to go to the model ribbon, and we're going to go down to datum here. Okay, we're going to down arrow. And we're going to go to curve, but don't press it yet. Go to curve with equation. So just hover over curve and it's going to get this flyout menu, curve from equation. We're going to click on that. And then you get a new ribbon here. Make sure that this is set at Cartesian, which it should be, the coordinate system. And what we're going to do is we are going to just kind of rotate our view here so that now they want us to choose the coordinate system origin. So we're going to click that origin in the middle of the screen. Okay. And you're going to see that it populates up here in the coordinate system. Right. And that's all you have to do there. Then we're going to change this Cartesian to cylindrical. Okay. And then we're going to click on edit. Now what's going to happen is we're going to get a similar dialog box, but it's not the same as what we did before. Notice that the values down here are T, R, theta, and Z. This is where we are going to take the equation of the line for the profile of that spur gear, and we're going to add the equations up here. So we're going to go back to our Word document that we downloaded earlier. We're going to go to the second page, okay? And right here, the equations for the involute tooth profile are what we want to copy. So right click copy, or you can do, what is it? Control C. And we're going to go back to Creo. Okay. And in the relations of this dialog box for the equation of our circle or our curve, we're just going to hit Control V or right click and hit paste. Okay. We want to verify. So we click that little thing there. Relations are verified successfully. We're going to hit OK. All right. And we just want to kind of see here that a couple things populated. So we're going to notice that T remains 0, which is okay. R is going to be 0.439846. And then TO degrees, 2 degrees, is going to be 57.29. The other ones are zeros. Okay, so that's totally fine. And now what we're going to do is we're going to click OK. What you are going to notice is that a curve was created here. Okay. So what you can do is if you tipped your view, just go back to view the front plane, and you are going to see that curve appear. Okay. That is one side of our involute tooth cut that we are going to use to create the rest of it. Okay. All right. All right. Green, we're going to click the green check mark, and now we go out of that. So that created our profile for us. Now what we want to do is you'll notice that a curve was created in our design tree. We want to rename that. Okay. And we're going to rename that to involute tooth profile. All right. So if we look back at our procedure, I just want to catch us up to where we were at. We renamed it. This was step number 10. Now we're going to be starting step 11. Okay. This is going to be the part where we're going to create the sketch for the actual cut that we're going to do. So go back over here. So we've got our 3 circles. Again, this is the base circle or the dedendum circle. This is the pitch diameter. And this is the outside of our tooth, like the very top of the tooth. Okay. And then right here, this is the start of that, that profile. Now, the first thing we're going to do is we are going to create an axis. Oh no, we're going to create the point first at the intersection of our involute tooth profile and the pitch diameter. Okay. So on our model tree, on our model ribbon, we're going to go point. And we're going to create a new point. I'm going to do shift and move over so we can see this at the same time. And I am going to select the pitch diameter, the middle one. And then I'm going to hold my control key and I'm going to select my curve. And I just created then a point at the intersection of those 2 items. You have to select, or you have to be holding the control key as you select both of them, okay, so that you get both of them. So I've got a point right there. I'm going to say, okay. Now, the next thing I'm going to do is I'm going to create an axis at the intersection of my right and front planes. So still on the ribbon here for the model, I'm going to create an axis, okay? And it's going to be at the intersection of my right plane. And then I'm going to click on Control and my top plane. And what has happened is you should see, now it's very faint here, you should see an axis that just created down the middle here. And if I go like this, it's like an axis that's coming through the origin at the intersection of the right and the top planes. And I'm going to hit OK. And now we can see it a little bit more clearly with that green away, right? So I just created a point and an axis that's in my tree over here. I'm not going to worry about renaming those. So A1 is my axis that I just created. Now I'm going to create a plane through the axis and the point. So still on my ribbon, I'm going to create a plane here. Okay. And you'll notice that it went through my, I'm going to start that over for a second. And I'm just going to say, you want to have this axis highlighted. I don't know if you did that or not. So depending, I still have mine highlighted. I'm going to hit the plane because I want it to go through that axis and then through the point that I also created. So now I'm going to hit Control and I'm going to click on that point. And now what you'll notice is there is now a plane that is rotating at its center on that axis that we created first and now out to that point. So these two are here. So now I can hit OK. And if I go to and I look straight on my front view, you are going to see, if you zoom in, the horizontal line is that top plane, and then this is slightly tipped up through the center of that point. Okay. All right. So where we are at. So we just created a plane through that axis and that point. View it from the front view. You should see that is slightly, higher than the top plane, which we saw. Now we're going to create another plane, which is going to be datum 2 through A1 and datum 1. Okay. And then we're going to rotate it 90 over N. So we'll see what that is in just a little bit. So I'm going to zoom out here a little bit. I'm going to create another plane. Okay. It's going to be datum 2. And I want it to go through that datum plane and through A1, which is my axis. So I'm going to do Control. Oopsie. I think I can grab it right from here. So you can also go on here in case you don't want to rotate it. So Control there. And I'm going to hit OK. Shoot. Undo that for a second. Let's do that one more time. I'm sorry. I hit OK before I put my value in. Plane. And I want to go through the axis and the point. So hit Control and click the point. No. I'm sorry. Do I really want to cancel? Yes. One more time. Let's read the instructions, Kelly. There's so many steps in this. So I'm going to create a plane. Okay, create a plane. And I'm going to go through my axis and datum 1, not the axis and the point. I already did that one. So plane through the axis and Control through datum 1. All right. And now what you're seeing here is it wants to know from that plane, how much do you want to rotate? Right now it's set at 45 degrees. Okay. And it's rotating upwards. What you want to do is you want to rotate this down. I'm going to left click and I'm just going to pull this down underneath here. Okay. So that's going to be my position because I want it down away from. And then we're going to put in 90 in this rotation, 90 divided by N. Okay. What that is 90 divided by the number of teeth that we already created as a relation. Our number of teeth was 12. Okay. So it's going to be 90 divided by 12. And we're going to hit OK. And it says, do you want N or 90 divided by N as a feature relation? Yes. Okay. And what happened here is you're going to notice that mine went above. I don't know why, because every other time I've done this, it's gone below. But if yours goes above, that's okay. all we have to do is we have to go back over here. We can hit OK. And we're just going to go back into datum 2 and we're going to edit that. And oh, no. You might have to, but go back. I don't think it's going to allow me to edit it. So I'm going to hit a cancel here. If yours is on top, do you really want to cancel? Yes. So instead of doing 90 over n, we're going to have to do negative 90 over n. That's all. So we're going to do a plane again. We get to do that one more time. We're going to go, it's through datum 2, and then control, we want to go through X. Yeah, through datum 2 plane and the axis A1. I'm second guessing myself now. So I want to do negative 90 over n. There we go. Put the negative in front, and we want it to be negative 90 over n. I'm just going to stop this for a second. We're going to resume the recording. All right, we're going to do this one more time. I am going to create a plane, and I want to reference my datum 1 and control axis 1. And then I'm going to do negative 90 divided by n, enter, and there we go. And I think you're right. I think I was clicking on that and doing the negative. So we want this plane to be down in the 4th quadrant, if you would, from the origin. And we want it to be 7.5 based on those relations. So now we can hit OK, and you'll notice that you have a datum 2 that was just created. There we go, finally. So, so now on our procedure, that brings us to the bottom here where we just created this datum 2. And now we can go to our step number 12. We're going to go back over here because we're in a sketch. And we're going to mirror our involute tooth over the datum that we just created. So we get it on the other side here. So we're going to select that curve. We're going to mirror it. And we're going to mirror it over the datum 2 that we just created. Okay, so that's the other side of the cut. And now we're going to hit OK. So now on our model, we have the 2 sides here. This is a good time to do a quick save so that we don't lose anything that we have. So I'm going to do a file, save, and hit, sorry, OK. Oops, I know this said there's 2 on the chat here. Oh, thank you. Yeah, I think I finally got it figured out. Thank you, Matt. All right. So now that we have this mirrored on this side, what we want to do is we want to create the rest of the cut. And we need to start a new sketch. So we're going to sketch. We're going to sketch on the front plane. I like to kind of rotate it and select it. I think that's easier. So I should be on my front plane here, and I'm going to hit sketch. And now what we're going to do is we're going to project those 2 curves into our current sketch because we started a new one. We're kind of blank slate. We're going to project this curve, hold your control key, and we want to do the other one. Okay. And then we're going to hit the green check mark. And now those are currently in our sketch. Now what we're going to do is we're going to create a line from the origin to the end point of each one of those curves. So I'm going to go first to my top one and make sure that you get the end point of it. Okay. And then I'm going to go back. I'm going to go there, and I'm going to go to the end point of this curve. Okay. Then the next thing I'm going to do, so I have now kind of this V here. These are the extensions of those lines. I'm going to create another circle starting at my origin, and it's going to go to the smallest circle. So kind of make it concentric if you would with that or equal to that. Okay. And then the other circle that we're going to create, we're going to start at the origin again, and we're going to go to the very outside circle. Okay. All right. And now we're going to trim away the parts that we don't want. Okay. The part that we want, the only part we want is on that inside part. This is going to be our cut. So I'll kind of show you. I'm going to do the delete segment. I'm going to get rid of all of the circles on the outside here first. Okay. So I'm going to get rid of all those. So I'm only left with these inside portions here. And then I'm just going to get rid of these two portions of the line there. And once I do that, you should get a pink like interior here that you have a solid section. Okay. So I got rid of all the areas out here. If you don't have a pink, you might have some lines hanging out over here. All right. This is our cut. This is our cut. So now we can click our feature requirements, make sure they're green, and hit OK. Now we're going to call this is the sketch of our sweep, if you would. So I'm going to rename this Sketch Tooth Profile Cut. So this is going to be what we're going to use for that sweep that we talked about. I'm going to do a quick save. And I'm going to go back to our procedure. So we are right here. We created the sketch for that sweep. Great time to regenerate and save as we just did. Now what we're going to do is we are going to extrude the feature for the outside diameter. Oh, no, wait. We're going to do the trajectory first. Okay, that makes sense. So we're going to create now. Okay. All right. So does it matter? I don't know if it matters which order we do this in. I don't think it does, but I'll do it in the order that it says there. So the next thing we want to do is we just want to create the diameter going backwards for the rest of the shaft. So I'm going to actually go underneath here so you understand. So if we look at our pinion shaft, what we have created is looking in the front view here, we have the profile of the tooth. I'm going to create now the diameter going to the back portion. So if this is a total of 5 inches long and the front part coming forward, so the front plane I have right at the front face of those teeth, I want to know what is the difference between, what is the length of this section of that shaft? So it will be 5 minus 1.1875. 5 minus 1.1875. So that'll be 3.8125 is going to be the length of my extrude. So what I'm going to do here is I am going to create an extrude. Okay, actually cancel that out. Do not have that sketch selected. So unselect that sketch and we're just going to do a regular extrude. And we are going to do it on the front plane. What the heck? And I'm in sketch now, so that's good. That's exactly where I wanted to be. It didn't look right. So now I'm going to do a circle and I'm going to make it larger than the outside there. Okay. And I'm going to hit okay. And then I'm going to double click on that diameter and you tell me which diameter, which relation do I want this diameter to be? I want it to be the largest circle on the outside. So do you remember what relation related to that outside circle? It was the addendum diameter, right? The DA was the largest circle on the outside. So we're going to double click on that and we're going to say DA, enter. And it's going to ask us, do we want this to be that DA relation? Yes, because then it's going to be exactly the size of the outsides of our teeth. That's exactly what we want. So we're going to say, okay. And now it made it that. Now you might say, couldn't we just attach to the outside of the teeth? We could, but then if anything changes, if we change the number of teeth, the diametral pitch, and we would want to make this a different size, this then continues to tie it to that relation as opposed to a point on the model. Does that make sense to everybody? So now we have this here, okay? And all we want to do is we want to check our feature requirements. We're going to hit okay. And we want this. Now here's our front plane. We want this to go back from the front plane. So we're going to change the direction so it goes back, because this front plane is where our sweep is going to start. And we want this dimension to be, what did I say? 3.8125. Okay, it's going to be a blind extrude back. And now we're going to simply hit okay. And we're going to hit okay. All right. So if we look here on the very front, we still have that sketch of that tooth profile that we're going to be cutting away. All right. Do a quick save. All right. Oh, it said we didn't regenerate. So regenerate and then save is fine. All right. All right. So now we're at like on the home stretch here. We are now going to create the trajectory for this sweep to take. Okay. So to do that, you're going to notice that the middle of the tooth is along that, along this datum 2. Okay, datum 2. So what we're going to do is we're going to use that as our sketching plane for our trajectory, because we need to look straight down at the middle of that tooth. And since it's at an angle, we can't take the top view or top plane. We have to look down this plane. So we're going to click on either place. We're going to click on this right here, and we're going to create a sketch. Okay, and this is going to be our trajectory. So now we're looking straight down at the top. Now it looks like the top. We're not on the top view, but we're looking straight down that datum 2. And what we want to do is we want to create our trajectory to start. It's going to be a line. It's going to start here at the bottom. Okay, and it's going to like, you know, grab that endpoint there of that radius. Okay, we're going to start there, and we're just going to go up a distance and then hit the middle mouse button. This distance is going to be the full tooth distance of 1 inch that we have on that drawing. So we're going to dimension. Actually, it is dimension. So we can just double click that length, or you can dimension it, and it's going to be 1 inch. So we just want that to be 1 inch there. Now, if we look back at the drawing, we created the line for the full 1 inch tooth. Now we need to create this radius, but you'll notice that they don't give us any information about that radius, do they? So this is one of those places that we have to improvise. Like we're gonna put it in. So I'm going to go back to Creo here, and I am going to create a circle. The circle center is going to be in line with the end of that 1 inch diameter. And I'm just going to go out here a random distance to the right. That's going to be the center of my circle. And then I'm going to go to, and I'm going to attach to the endpoint of that 1 inch dimension. Okay. And then I'm going to middle mouse button, and I'm going to change this value to a 4 inch diameter. That's it. Okay. So this is going to be a radius of 2 coming out. All right. Now, I needed to follow that path along that, but not do the whole circle. Okay. So we need to kind of cut that off. So I'm going to put in 2 lines. I'm going to do a line from my endpoint of my 1 inch. Wait, that didn't happen correctly. Hold on. A line from here, my quadrant to the center. And then I'm just going to go right about there. Okay. Right about there. So you're going to create a little V if you would. Correct. This is going to be normal, or at that endpoint of that 1 inch dimension that we created. My 1 inch dimension is from here to here. Right here. It's on the edge of the part. Yeah. So this line is on the edge of the part going straight up 1 inch. And then my center of my circle is 1 inch from, and then it's a radius of 2. It's right here. So once I have this at 45 degrees, you want to change this angle to 45 degrees. I now want to get rid of the segments that I don't want. So I just want to be left with my trajectory. So I'm going to click on delete segment. I'm going to get rid of this part, this part, this part, and don't forget this little part right here. So the only part of the trajectory I want is the 1 inch coming up on the side and then the radius going out for about 45 degrees. That's it. That's all that I want. All right. So once I have that, you can check your feature requirements. I'm good. And I'm going to accept this sketch. Okay. I'm going to accept that sketch. Now, if I look at that sketch, all that is it is just this trajectory right here. That's all that is. So we're going to rename this. And this is going to be trajectory. Okay. All right. Now we're ready for our sweep. So we have our extrusion, we have our outside diameter in here, we have our trajectory, and we have the profile of the tooth that we want to cut away. So we are going to do the sweep command. The sweep command is just to the right of the extrude. And this is just going to be a regular sweep. If we click down on here, there's a couple different types, but we're just going to do the regular one. Now what we're going to do, the first thing it wants us to do is identify our trajectory. It already selected it for us, okay? If yours isn't selected, just go ahead and select trajectory, okay? I had my trajectory path sketch selected as I went into this command, okay? It doesn't have to be. Now, the thing that we want to do is this, if we look at the trajectory right now, I have my purple arrow at the end of my line. I actually want to move that to the beginning. So you're just going to left click and you're going to drag it to the front of your line. That's it. And what's going to, and we want it to go right here. And right there, it should start at the, did mine go? I think so. Yeah. So you want to be sure that your purple is at the start and that your green extends. I'm not sure why that one grabbed, but my green endpoint extends all the way up to the end of that trajectory. So you want it to be green with the arrow starting at the very front, okay, of our cut. Then what we're going to do is once we have that identified. So again, you want to bring your green arrow back to the beginning and then switch your green so that the whole line is green with your arrow pointing away. Does everybody have that? Yeah, you would click on that. You see how my arrow got kind of small here, but should be good. Now we have the trajectory identified. We now need to tell it what it needs to actually push along that path. So we are going to do a sketch. Okay. Now we already have the sketch here. Mine positioned itself backwards, but we're going to go back to the front if you need to. And we are simply going to project all of the elements of our profile. So I'm going to select the first one, hit the control key, hold it, and go all the way around to select all the elements of this profile. Now, what you have to do is you're going to have to go along this line and you have to get it when it's just the in-between part. Otherwise, you're going to have to do some trimming. So it's right there. So if you kind of move along that line, right again, hold on. So annoying. So along here, this is taking the one side, this is taking the other. And if you go in the middle, well, I'll just trim away the parts I don't want. Hold on. You have to hit sketch. And then we're going to project that sketch in here. Is it gonna go for me? Do that one, accept. And now all of those elements are in here. I'm gonna get rid of this part, and make sure that there's one little part right here. Get rid of that. And now all I have left is the inside right here. Just want to be sure. So you can use your feature requirements, it's okay. And now you can hit okay. So we just projected that previous sketch into this sketch. Now, if you get something that looks like this, you're on the right track. So what it's done is it's extruded added material along that path, but we want to remove material. So all we have to do is toggle the settings up here to remove material. And now here is that cut. Gonna hit okay. All right. Resume recording. So now we're just going to rename that sweep tooth profile cut. We're going to select it and go up to pattern. Now over on pattern, the type of pattern that we're going to do is we're going to rotate it around an axis. So we're going to select axis. And then I think I got to just select the axis in the middle here. And now it's going to start by adding my elements here. We want our, the number to be 12 in the first direction members. And then we are not going to do angle between. We're going to click on angle extent, and then make sure that that's 360 degrees. And now you're going to notice that it's going to place 12 of them around the outside. Okay. So then I'm simply going to hit okay. Of course. This is the way this is going. Hold on. I did go around, but that would have been a problem on the sweep. Yeah, so that was just left over, but for some reason my pattern didn't work the first time, but it seems to now. So make sure that you change the type to axis. You select that center axis here. Change your number to 12. The angle extends to 360, and I don't think I did anything different, but maybe I did. And you're just going to hit okay here. And now it's going to cut the 12 around on your profile. Now, as we look at our instructions here, you're going to notice that we created our sweep. We went through, we renamed that sweep, and then we patterned the 12 teeth around that shaft. Now, the only thing to add to this pinion shaft are the last two features. You need to add an extrusion coming forward for the dimension that we see here, about 3/4 of an inch. And you need to add the hole going through the back end here, and that's going to be the hole that handle goes through. Okay. And I'm going to let you guys finish that up because those are just two additional features to add here. The big part of this was putting the teeth around the outside. James, did you have a question? Oh, the screw hole on the back. You're correct. Yes. So yeah, he said there's this right here. I forgot. Yes. So there's a third feature where there's a 1/4-20 screw hole. Thank you. So that's what's left on that feature. So, so what I'll do is I'll post this, if you need to go back and, reference it, but hopefully you were able to follow along. I know it's a pretty complicated procedure, but with the way Creo is set up in our licensing right now, manually putting this in this way is, how we've got to do it. So I am going to stop the recording.